Welcome to The Explainer. Today, we're going to dive into one of your body's most productive and, honestly, most amazing systems. A sort of hidden factory that's working 24/7 to manufacture the very essence of your life, your blood.
Take a look at this number, 1 trillion. Get this, that is roughly how many new red blood cells your body needs to make every single day just to keep everything running. I mean, that's just an astronomical figure, a massive production line humming away inside you right this very second.
So, a number like that, it just makes you wonder, right? How in the world does our body pull off this incredible, non-stop manufacturing job? Where's the factory floor for all of this? Well, the answer is something called the hematopoietic system. Now, this isn't like your heart or your lungs. It's not one single organ in one spot. You got to think of it more like a super sophisticated distributed factory that produces every single red cell, white cell, and platelet you have for your entire life. All right, so here's our game plan for this explainer. We're going to start with the factory's master blueprint, then we'll see how its location actually changes as we grow. We'll tour the adult headquarters, visit some specialized departments, and wrap up by talking about why this whole system is just so critical. Okay, let's jump right in. Every great factory needs a master blueprint, right? A single design that you can use to make all the final products. Well, for our blood factory, that blueprint is the hematopoietic stem cell.
This right here is the hematopoietic stem cell, or HSC for short. And this cell is, well, it's incredible. It basically has two superpowers. First, it can self-renew, meaning it makes perfect copies of itself so the factory never ever runs out of blueprints. And second, it can differentiate into any type of blood cell the body needs. It's the ultimate ancestor.
So, how do we get from a blueprint to a finished product? It happens in stages. The stem cell first turns into what we call progenitor cells. You can think of these as the different assembly lines. You've got the myeloid line for red cells and platelets, and the lymphoid line for immune cells. These progenitors then multiply and mature into the final, fully functional cells that get shipped out into our bloodstream. Now here's where it gets really cool. This factory of ours, it doesn't just stay in one place its whole life. No way. The main location for blood production actually moves around as we develop, from embryo all the way to adult.
And this timeline shows that journey perfectly. When we're just an embryo, for the first couple of months, it all starts in a place called the yolk sac. Then, the operation moves to the liver and the spleen, which become the main production hubs. Right around birth, the whole operation shifts again, this time to the bone marrow. Now in babies, pretty much all their bones are active factories. But as we grow into adults, it consolidates, mainly running out of our central skeleton. You know, the vertebrae, ribs, and pelvis.
So let's focus on where this factory finally settles down, the adult headquarters inside the bone marrow. And it's not just one big open space, it's got different zones with different purposes.
Inside our bones, you've got two kinds of marrow. There's the red marrow, that's the bustling factory floor, the part that's actively cranking out new blood cells. And then there's yellow marrow, which is mostly just inactive, fatty tissue. But, and this is the big but, it's not useless. It's a critical energy reserve, and if your body's in trouble, say after a major blood loss, it can actually convert this yellow marrow back into productive red marrow to ramp up production.
And you might find this surprising, but even in the bones of a healthy adult that are working the hardest to make blood, about half the space is actually this fatty yellow marrow. It just goes to show you how much backup capacity is built right into the system from the get-go.
Okay, so the bone marrow is the main production site, right? But the whole hematopoietic system also relies on other organs that act like specialized departments, and each one has a really critical job to do.
First up, you've got the spleen. Think of this as the factory's quality control and recycling department. Seriously, blood flows through these super narrow passages, and it's like a stress test for red blood cells. If a cell is old or damaged, it can't squeeze through. So it gets pulled from circulation, broken down, and its valuable parts, like iron, get recycled for new cells. So efficient!
Next, we have the thymus. This place is like a super exclusive training academy, a boot camp, really. This is where a special type of immune cell, the T lymphocyte, goes to mature. They travel here from the bone marrow, and in the thymus, they learn the absolutely critical skill of telling the difference between your own body cells and foreign invaders. It's boot camp for your immune system's special forces.
And finally, let's talk about the lymph nodes. You've got these scattered all over your body, and they act like regional security hubs. They're constantly filtering fluid, trapping any bacteria or viruses they find. And when they detect an intruder, they activate the immune cells inside and launch a targeted attack to stop the infection right there.
All right, so we've been on a tour of the factory floor and its different departments. Let's kind of pull this all together and talk about why this whole operation is just so unbelievably important for our survival. I mean, at the end of the day, this system is doing things we literally cannot live without. Its red cells carry all our oxygen. Its massive army of white cells protects us from disease. Its platelets are there to form clots and stop us from bleeding. Without this constant production, all of these critical functions would just stop. But get this, here is one of the coolest parts about the whole system. If the main factory in the bone marrow ever gets damaged or starts to fail, the liver and spleen can actually fire back up and start making blood cells again, just like they did when we were a fetus. It's an incredible built-in backup plan, a testament to the body's resilience.
And all this brings us to a really fascinating final thought. As we get better and better at understanding stem cells and how this all works, you have to wonder, could we one day harness this process? Could we learn to build these little blood factories on demand to create personalized treatments for everything from anemia to cancer? The body's own blueprint is right there, just waiting for us to fully decode it.